All right, so we're now recording. So again, thank you all so much for joining the call today. I really appreciate you for joining. So welcome everyone. Welcome everyone from AIA, from all the inspectors that participate in the survey. There's probably also some representatives from APHIS on this call. So thank you so much for joining. So the topic of today's talk is navigating the BIP research portal. So all of the data, and many of you may not know this, but all of the data of the National Honeybee Survey, since it began 10 years ago, has been stored on BIP's database, Bee Informed Partnership. They have done so much to support us since the very beginning, and the data has continued to be stored there on their secure servers. So everything in this database allows me to make reports. So when you get reports from me, I make them through this database, which is really helpful. Karen can probably tell you, she's on the call, when the survey first began, all the reports were actually made by hand. So lots of copying and pasting and room for error. So now we've taken all of that risk out in having this. And it's important to us to keep beekeepers' identities confidential. So all of that information is very secure, but while we keep that secure, we can also have data online for the public to view. And we realize that it's not exactly obvious to a lot of people that you can see all of this honeybee disease and pest data online. So that's what we're going to show you today, what we have, and then future plans, because this is always evolving. It's always being improved upon. And before we get into that, I'm actually going to talk a little bit. We have a new National Honeybee Survey website, and I'm just going to show you guys that real quick. So let's see here. I'm going to stop my share here for a minute. All right. Why is it not popping up? Oh, that's why. All right. Thanks for bearing with me here. Okay, so this is our new website that we've started with our new domain name, which is ushoneybeesurvey.info. And the idea behind this website is we really wanted to start something where it has all the survey info in one place, and it makes it really easy for all the participants to find what they need. So the main page is just a summary about what the survey is, where the samples are tested, et cetera, et cetera. And if we go over to the main menu at the top, we've actually started a blog. There's only one right now that I wrote, but I have works to create a new one soon. So that's going to be something that we're going to updating, periodically within every couple of months. The goal is to have a new blog. And then when I was talking about resources for participants, inspectors that are part of the survey, that's this page right here. So everything in this page, is being updated as soon as we have it. So if you're ever looking for any documents that you need, for example, like protocols, you have that here. These are the most up-to-date ones. We even have a promotional PDF that you can use to advertise to find beekeepers to participate in the survey. We have our past summary reports. So that's everything here. And let's see here. And, this is something we're still working on. So obviously it can be improved, but Nathan did an awesome job in this. And here you'll see videos. That'll be where I will post this recording after we're done. So right now it's mostly sampling videos and things like that. So that being said, this is where we're going to start talking about the research portal. And I am going to share again. So Michaela is going to take the lead with this, but I'm going to continue. We're going to kind of go back and forth. So you're going to see everything on this on Michaela's screen, but in case you would like to open up a browser and do your own thing as Michaela is talking, this is the URL right here. So research.beinformed.org, and this will bring up the main page. Okay, so at this moment, I would like to introduce Michaela, who is on this call. Michaela is the Be Informed Partnership IT Data Sleuth. So Michaela is the #1 IT person for Be Informed Partnership. Michaela's team built everything that we are going to see today from the ground up, which is really amazing. She's going to walk us through the database step by step, and we're going to share everything with you that can be viewed and everything it has to offer. So, Michaela, if you would like to share your screen, and then we can get started.
Okay, thank you.
Mm-hmm.
And yes, thanks for having me here. And do you see my screen there?
Yes.
Look right. Okay. And here we are at the research.beinformed.org website. And there's a number of different projects here, as Rachel alluded to. And in the upper right corner, you can see where you can log in. But for what we're going to look at today, you don't need a login or account or anything. Pretty much that's, for most people, that would only be if you want to access the hive scale monitoring part of the database. But on this front page, you're going to, if we scroll down, there's a number of different projects where you can access the data visualizations to those projects. And we're going to go down here to the APHIS state reports and look at that. And we'll also at least look at this virus map as well. That maps some of the viral data that's been collected. So I'm going to click on the APHIS reports, and that brings up this page here. And so where all this came from, as far as combining the APHIS data into the Be Informed Partnership database, back in 2011 and 12, we were awarded a USDA NIFA grant, where one of the objectives was to bring together a number of US or honeybee health databases to a single area, and along with forming the Be Informed Partnership nonprofit. And so even in 2012, we were using a database. It was different than this one, but it was an online database of these combined projects to generate those reports. And then towards the end of that grant in 2016, we released this data view you see here, and there's been numerous improvements on it since then. Let's see. And so, as Rachel mentioned, the data is being entered in here, and the reports are being generated. But to get to any of the personal private information, the general public is not going to be able to get to that. So that's where their logins come in, and people, the way it's set up is people that are working on the APHIS project, they only need permission to see just that APHIS data. So for example, if someone's working on tech team data or some other project, they can only log in and see the data that they're working with.
That's correct. This is, I think, a really fitting map to have first thing. and that's Varroa. So this map is all the National Honeybee Survey data on Varroa levels. So to me, it looks like the darker the color, the higher the Varroa, right? And then this is, you can search by year.
Yes, that's right. So there's this little drop-down menu right here that we can select different years. And as we select different years, the map is changing here. And it really, the map is just intended to give you an idea of what states, we have data for per year. And then, we color them by showing the average Varroa level. And these white states, of course, don't have any data. And we've got Washington, D.C. up here now. That wasn't there a few months ago. We have that there now. And we have Guam and Puerto Rico, Alaska as well. And so as you're changing the year on here, it doesn't just change the map, it changes the number of these charts that are down below. And we can look through what charts we have here. So we have, break down this average Varroa level by month for both all years of survey data or the year that you're looking at up at the top in this menu, drop down. And the black line there is for all years, and so it gives you that idea of the average seasonal levels of Varroa and Nosema, and we can compare the month of that year and see if any, you might notice if any particular year was, higher or lower than average compared to other years. These bars each have a error bar at the top, the blue bars do, and that's the confidence interval. And that gives you an idea of the range of data within that bar. So the average here in October is 5.7, and the confidence intervals between 4.5 to almost 7 there. And so that's fairly close together, whereas over here in Nosema, the January Nosema level is, had a lot more variation in that data. So that's what those lines are for. And of course, we also have the molecular pathogens that are being tested for, and they're listed here as what they are. We have now renamed VDV on this website to DWVB, which is becoming more of the convention of that virus. And the old DWV is now, we're now calling that DWVA. And then there's new viruses being tested for Moku virus, and we've been testing for Nosema ceranae for a while.
Yeah, so Moku virus, I just wanted to jump in and talk about Moku virus a little bit. So Moku virus is something new that we're looking for. Well, not necessarily new, it's just something that's newly being looked at. So this virus has been found in wasps, and we're kind of keeping an eye on it to see, scientists don't know much about this virus at all. We don't know if it's good. We don't know if it's bad. We don't know if it's good for honeybees. Not that that's, maybe it's just indifferent, but so this is something, that we're just looking at for the survey. So again, one of the best things about the survey is we're looking for new emerging viruses. So this list is constantly changing. Throughout the years, new viruses have been added, and we're always looking in the literature to see what's emerging.
Yeah, and so this pathogen prevalence chart is the prevalence would be out of this, if all the samples were positive for deforming virus, that would be a prevalence of 100%. So in this case, we see that for all years, DWVA, 72 or 80% of the samples were positive for that. And then 2018 data was a little bit lower at 72%. So you can look and see for
Mhm.
any year was, again, was that prevalence higher or lower than all years combined, and see what's the most common viruses and what's the rare ones. And there's some notes here about a change in 2013 uh, about how that data was collected. So most of the data you're going to see with viruses is post 2013.
Yes, that's correct. In 2013, we changed our molecular methodology. Nathan Asherfund will be able to speak more on that, but basically we went from just doing positive and negative to quantifying, so quantitative PCR. So all the data that you see here is only 2013 and newer. We have, the previous year's data, but we only have prevalence for that. So again, positive or negative prior to 2013.
And speaking of changing protocols, we have pesticide sampling, and over the years that's been done with either bee bread sample or the wax pesticide sample. So depending on what year you're looking at, these charts may, instead of saying wax, they say bee bread, and that's all going to happen dynamically and let you know what you're looking at.
Yes. So, and the reason that there's two different materials that we are looking at for pesticides is because wax and bee bread cover different pesticide pathways within the hive. So wax retains pesticides for an incredibly long time. Um, and it's seen more as a historic record of a hive's pesticide exposure. So, each season a hive might be exposed to different pesticides and that wax just holds on to it. So in contrast, bee bread is more of a snapshot. So, you might get a little bit of transfer from the wax, from pesticides from the wax into the bee bread, but most of that will be pesticide exposure from, for example, that season. So periodically we're going to, switch from one or to the other. So, for 2020, we went back to bee bread after we had switched to wax. So it just makes things nice and complicated for Michaela, but she has set up the database so only bee bread is compared to bee bread and only wax is compared to wax. And Michaela is going to show you that because the histograms is drastically different between bee bread and wax. So again, just to reiterate, how wax just has from what we've seen from the survey, just has a lot of pesticides in it, whereas bee bread is on the lower end.
Yeah, so let's look at these charts for wax, and then we'll switch them to bee bread, and you'll see that. These two charts on the left, again, now we're looking at all the wax samples that we have in the database. And on the right is we're pulling out just those 2018 samples. So you can see if, for example, the varroicides changed, the percent of varroicides changed, which they didn't. They were about the same. So these two pie charts are just kind of a breakdown of general categories that are being found. There's 730 total pesticide samples, but each one of those pesticide samples is tested for about 200 or so pesticides. So you can have, so we have, thousands of records of fungicides being found and herbicides and things. The histogram that's on the bottom here is showing us the number of pesticides found in each sample. So for 0, there were no samples that came in of wax that had 0 pesticides found. And here, if we hover over this bar, we'll see that 3 samples had 1 pesticide detected, then 8, 2, and it goes up and kind of peaks in this general area around 10 to 12. And then you can have as many as 38 pesticides in one sample showing up here. And it's similar, you know, in 2018. Of course, less data, um, but a similar kind of shape to that histogram. So now if we go up to the top, though, and switch to a year with bee bread, we come back down here and see that our histogram for 0 pesticides detected, there was 193 samples with nothing found in them. So, um, and then, you know, the most of the samples are coming in, you know, in this area of the histogram, and we're not seeing those totals go up as high as they do in the bee bread as the wax. And there's a little bit of change up here as well. We can see that there's a higher percentage of Varroa looking at the bee bread than there was in the wax. But there's 2 other links here for bee bread and wax, no matter which year you're looking at. And if you click on those, you get a more complete list of what all is being tested for and what all has been detected. And there's going to be a table here of everything that's been detected. And then the bottom is going to be a list of anything that's been tested, whether it's detected or not. But this particular table has a feature I want to be sure to point out where you can sort it. And probably the most you know, interesting sort would be if you click on the sort it by the prevalence, the descending manner. That's going to list these out in the order that, you know, they are most prevalent or most common. So the most prevalent pesticide detected was the 2,4-DMPF, which is the amitraz metabolite, and then fluvalenic, mosylphosphimol. So the top things being detected are these Varroa. And then you start seeing what, you know, are the most common compounds that are not for Varroa with or papyrus and these other things. And you get the average level found and the range of the levels. Trace is going, of course, you know, it's detected at a low amount, but it can't be quantified exactly. And if it's trace, then it's below this LOD or this level of detection. And of course, you can see how many samples are being tested here for each compound. And if we go back to the wax, it has the same type chart, except now we're looking at wax. And so if we want to look at the same kind of thing, we could do that. And see, now we have it, you know, a different order. You know, we're seeing cumulphos, and then I'm not sure what this one is. And thymol fluvalinate, and then there's that amitraz metabolite, and then other things coming down here. So that pretty much covers what all is on this first page.
Yeah, so at this time, we're going to take just a little break, and I'm going to ask Nathan. So Nathan, is there any questions that we should answer at this time?
So yeah, I'll take ask the question. We got a question from Blaine White on the Varroa map up there at the top that's displayed right now. Is there any indication of when in the year the samples were collected?
Yes, and we could jump ahead to the next part of the talk, but maybe I will just do a quick jump ahead just to answer that question and come back to question. So for example, any of these states you hover over and you get that average, if you click on that state, it's going to give you the year that you had selected and then the state that you selected. And the first chart on that is going to be to where you can answer that question of when were those samples taken. And we again have the national trend line. This is going to be all data combined to give you an idea of what that seasonal trend is. And then just this Pennsylvania 2018 samples and when they were taken. And so, of course, if a state took all their samples early in the year, the average should be lower. If they take all their samples late in the year, the average should be higher.
Great. And then, yeah, this next question also will take us, segue us nicely into the next part. Can you download this data, or are you only able to take the image of the graph off the website?
Okay. Well, do we want to get into showing how to do that, or is there any other questions? Or?
No, yeah, go ahead. Oh.
Okay. So we'll go back to Pennsylvania here. And so we have the average Varroa map we just looked at, and then we also have the same thing for Nosema, so you get to see what's going on there. And again, you can hover over these and get, you know, the May number, that's 3 samples, 7 samples here. And now, instead of showing the confidence interval, we're showing, for these error bars, we're showing the actual minimum and maximum value. And and let's see, let's just go ahead and look at everything here. So we looked at the pathogen prevalence chart there for the year, but now we're seeing just for Pennsylvania in 2018, again, compared to the national. So you can get a further drill down of that. We can come back to this chart later. Then at the bottom, you're going to get each sample in a table that came out of Pennsylvania for 2018, showed here. And if anything was tested, if the sample was tested for pesticides, any positive results will be shown here. If this is blank, then that means there was no pesticides sample. Wax is indicating that it was a wax sample, not a bee-bred one. And we're giving the, you know, the month, the county it came from, then that average levels there. And then for the molecular targets through here, we are putting them in a category if they're positive of a percentile. So something that's below the 30th percentile, you would consider as a low level of deformed wheat virus B, whereas 50th would be like kind of right in the middle range, and then of course 80th or 90th would be a high level of the target found. And these little dashes are negatives. So May, Delaware County, you had 3 positive targets, A, B, and LC2.
And
But,
Michaela, if there's a blank space in the pesticide column, what does that mean? Does that mean it wasn't tested for pesticides?
yeah, this one didn't have pesticides tested for it in it. And it looks like some of these were tested for the MKV, were not tested for the MKV virus, whereas for Moku virus, and then some of them were tested for Moku virus. So you get the negatives showing up here. And we have the highlighting going on if the Varroa levels exceeding threshold. But the question that brought us here was if you can download this data. And it's pretty easy to copy and paste this and put it in Excel. It's just a plain HTML table. So I'll show you how to do that. You just want to take your cursor, stick it right in front of the first letter at the beginning of the table, drag down to the bottom and end at right at the last character at the bottom of the table. And I'll let go, and I have that highlighted now. And I could do a left click copy, or a Control C or on a Mac, or a Command C on a Mac, or a Control C on Windows. And then I bring up Excel, the table, go right there and do a Command V, paste that into the spreadsheet. And that gives you all the data there, and some of it can be quite easier to look at in Excel there. If you want to look at some of these pesticides that are being found.
Yeah, and if you ever, want this data in a different format, if you're a state bee inspector, you can reach out to me and I can give that data specific for your state.
Yes, I think this is the contact email for that right here. Is that
Yes.
correct? Okay. And so, yeah, if you're looking at this, be sure to check out all these notes. This is going to, you know, cover information we're talking about here, but help you remember. Was there other questions, Nathan?
I had a question, Michaela.
Go ahead.
So going back to those pesticide pie charts, I noticed that there was a high number of positives. So why is that when there's only like 700 samples, but then you have N, 3,000 for Varroa side?
Okay, yeah. These N's are always the number of samples or the N value. And so of these 730 wax samples, each one of those was tested for near 200 different compounds. And so, one sample could, have a number of fungicides detected in it, or a number of herbicides and insecticides. So that's how we get these high numbers. And even each, well, actually, the way we had it set up, each pesticide is just a single category. But so it's just coming from the fact that each sample has hundreds of compounds being tested for.
Yes, and if anyone on this call would like to know what categories we have the pesticides in, just reach out to us and we can quickly share that with you. It's just an Excel spreadsheet saying, which ones are herbicides, which ones are fungicides, etc. So.
Yeah, and I suppose if anyone on the call did their samples earlier last year, or I'm not sure what the state is, they may have not seen the new reports that go out to the beekeepers. Any pesticide detected is going to have that kind of information included now in the report. Some information about what the pesticide is and what it's used for and things like that.
That's a really good point. I'm glad you brought that up. Yeah, so we redid the pesticide reports, so they're much more informative now, and I think they're a lot better for the beekeepers in understanding what the results are for their pesticide sample. So
yeah, as part of another grant, you don't see it here, but we've talked about how to begin incorporating this data. Say we'll just call it metadata about the pesticides, but that data is going into the individual report that gets emailed out, and we can work towards including that here later on. But that kind of data is the LD50 data, the data that is or the level that is considered harmful to the bees that will kill half of the population in the test. And from that, we're calculating hazard quotients to give a better idea of, if you find these compounds at these levels, is that a risk or not? And we can now have data to give some indication of that, and also, of course, the data that just explains what the pesticides are. And all that is in the back end of this database, so that it can easily be connected to the results when we need it. And so this is where we are at now with the open data view, but there is plans to do more with this.
yeah. So really quick before we go to questions again, Michaela, do you mind showing the virus heat map?
Oh, right. Yes.
Yeah.
So
So this is just the last bit of APHIS data that's in it, and it's this actually isn't just APHIS data, it's also the Bee Informed Partnership Tech Team data. It's all in one map, but I will let Michaela show that to you.
okay, yeah, so we don't have to go back to the home page to get over there. We can just go up to this open data thing, and it shows us the different data views, and we can go to the virus map, and it brings up similar kind of map, but now we're looking at the year 2019 with the prevalence of deforming virus A, and it's a prevalence again. So if it's 100% prevalent, it's going to be the darkest orange. If it's 0, like down in Guam, where I guess don't have a lot of Varroa problems, then it will be green. And this changes again dynamically. If you change the year, you can see, changes by year, or you can change the target and see the differences. And so some of these more rare viruses, of course, will be more green, and between years, you may see more variation in the differences. And these numbers that are showing up on each state is the number of samples going into that prevalence calculation. And hovering over Illinois here, IPV was 42% at 2012 out of 12 samples, and this sources in, under the samples in, sources means 12 different apiaries, 12 different locations. Whereas, if there was something over here in California, there was 576 samples, but from just 47 different places. And we can see which months those samples were taken: January, February, March, August, November, because the time of year can affect these results as well. Let's see. So if we go down to the notes, we'll see what Rachel was saying about it combines data from different projects. So it's not just APHIS data. That's why there's so many samples out of California that year. In any given year, someone may have been doing a special project in a state, and so that data will be reflected here.
Yeah, and I would also like to point out that this is by calendar year. So you may know for the National Honeybee Survey, our years are a bit interesting. So we'll go, for example, 2019 and 2020, whereas this is by calendar year. So if you see something that, you're not really sure, like, oh, why is it only like 14 of samples showing up, whereas I know I did 24 that year. It's per calendar year, not survey year. And that's the same with the other maps. So like the Varroa map that Michaela showed you, that's also the same case. So it's not by survey year, it's by calendar year.
Yeah, that's a good point. Thank you.
All right, so I think at this moment, Nathan, we're ready to answer questions again.
Sure, I've got 3 questions here. So the first question, can you see the results for different species of Nosema?
Well, we just are, for the molecular, we're just doing Nosema ceranae. Do you have anything to add?
So right now we're only testing for Nosema ceranae. I can't recall what survey year is, but a while back we tested for both, and we didn't find Nosema apis, so we stopped looking for it molecularly. But I think, I don't know, we may end up adding it back in at some point to test for apis again. But as of right now, we're only testing for Nosema cerana. But we also look at microscopic counts. So you have 2 different ways that we're looking for Nosema. So you have the molecular, and then you have the microscopic. The molecular is always going to be more accurate. So just keep that in mind.
All right, next question. Is there a way to see the quantification of the virus results?
So the quantification isn't available to be viewed on the public maps as of right now.
Yeah, the closest thing you'll get is the percentage, the percentile on the state reports, but that's not the exact numbers. All right, and then the last question. So what is the easiest way to save one of these graphs as an image?
Oh, yes. So each one of these charts we're looking at, they all come from the same kind of back end. High charts is the name. It's a little logo right here. And you can click on this little hamburger icon here, and you can download the image, or you can just print it to PDF or paper. PNG usually works best, and it may look a little different than it looks here, but bring that up, and there you go. You can print that off. So that, like I said, the same's true over here for these types of charts. You can download that PNG and bring that up. You can put that in any presentations you're giving, and we try to make sure that the headings give you enough information there to where it came from.
And that is all the questions I have.
All right, so at this moment, this is everything that we wanted to show you today. So I'd like to open it up. So if anyone would have any other questions they want to talk about now, please do. Oh, before we do that, I just wanted to talk about it here. So the 2019 survey, because of everything with the lockdown with COVID and everything, we haven't yet set a final date to send in samples. And it looks like we're going to set that as mid-August. And I'm going to send out an email soon, probably next week, just as a reminder. So if you have any 2019 samples that you're still working on, if you can get that to us by mid-August, that would be fantastic. And some other good news is Nathan and Asher Fun are able to return to their lab now and do viral work again, although on a limited basis, but so they can work safely. But we are, kind of getting back into the swing of things right now. So as of right now, if anyone would like to ask any questions, anything you want to talk about survey related, feel free.
I did just have a question come in
Okay.
as well. Maybe they might not be able to ask themselves, so I'll take care of it. Can we get the result charts by county?
No, I guess there's not currently a way to break that down by county on the Data Explorer. The county numbers are given, they're in the tables
Here,
at the bottom of those state pages, but yes, no actual charts are being rendered.
Let me pull up. I'm gonna steal the share.
Okay.
All right. You see my window. So yeah, in just a random state. So that, yeah, in the table here, the counties are displayed. So you'd have to grab the data yourself to see that visualized. Nothing on the website itself currently does that.
I've also had a few inspectors ask me about 2019 pesticide samples. So unfortunately that was kind of delayed due to COVID, but the good news is that last week I shipped out, like 150 wax samples to the USDA AMS lab. So it's now in their hands. So they're going to start processing them again. And I heard from Heather, who I work with in the UMD lab, who also sends samples, that they have been really quick at returning samples or results. She had a sample and it took 5 weeks to get results back, which is amazing. We've never had them be that quick. So I have hope that they will get us results soon. But yeah, so we're getting those samples out. So hopefully soon, within the next month, I can, next month or two, I can start sending out pesticide results for 2019.
All right, a couple more questions came in.
Okay.
So we have, could we go over the best way to take the bee bread or wax samples?
Okay. So, so wax samples, the best way to do the wax sampling is to take your hive tool and just kind of twist your hive tool. So find a spot in the frame. So after you've done your bump sample, so there's no bees on the frame, you can clearly see where there's no wax or pollen or honey. So try to find a spot that doesn't have anything in it. Stick your hive tool in the wax and do a quarter turn and then pull that out. And you do that for each of the 8 colonies that you sample for bees. So at the end, you have a nice tube of little pieces of wax all together. For bee bread, it's a little bit different. You have to, in each, after you do your bump sample, I've included wooden coffee stirrers. So you have to go into each cell with that stick and pull out the bee bread and put it in your tube. And that is definitely more, I guess, labor intensive than the wax sampling. But that being said, we only need, I believe it's 2 or 3 grams of material for the lab to test it, that we send it to. So they only need a couple grams. So you don't need, you know, it's easy to get a lot of wax, but with when you're looking between the 2 samples, the wax sample will be huge, and the bee bread sample is definitely going to be small, because we don't want you guys out there, you know, picking at these cells and the heat and everything. So with each hive or each frame that you do, pick out, you know, 3 or 4 cells of bee bread and then move on to the next one.
And we do have videos for both of those on the US Honeybee Health Survey.info. So if you click there and go to the menu and look at videos, there's a video for each of those sampling protocols. All right, next question. Would it be possible to add tracheal mites to the survey?
I believe way back when in the beginning it was part of the survey, but we don't look for it anymore. One of the reasons is because tracheal mites is pretty rare to find these days, and one of the reasons I think it might be is because like the Varroa treatments are also taking care of the tracheal mites. I don't foresee us adding it to the survey just because it takes a really long time to dissect the bees and look at their trachea. Ashrafan, who is in our lab, is really good at it, but she's definitely better suited for doing molecular work. But for that, if you're interested in tracheal mites and having bees, or if any of your beekeepers want their samples looked at for tracheal mites, definitely reach out to Sam Aban at the USDA Bee Research Lab. And that's something that he does for free. I'm not sure if he's taking samples right now though because of COVID. So if anyone knows if Sam Aban is doing that, please jump in and let us know. I don't know if he's doing it right now, although hopefully soon.
All right, another question. Have all of the 2020 bee survey kits gone out yet for all the states? 2020?
Mm-hmm. Yeah, so there's still a few states that I haven't sent your kits out yet, so I apologize. I wasn't able to get them all out before I left for vacation. I'm actually visiting family in Wisconsin right now. But I do have all the kit supplies in my house. So if you haven't received your kit yet, feel free to email me and poke me some more so that way I get those out for you. So I apologize if you haven't. Again, it should be only a few. Most of the states have received their kits now. So.
Cool. Another question. I've got a few more questions. So, is it possible to see the LD50 values on the results table highlighted I'm sorry if I'm asking this incorrectly, like the Varroa and the Nosema are highlighted on the table. So if a pesticide is detected above the LD50 level on the results table, could it be highlighted like the highlights on the Varroa and Nosema?
Yeah, we've looked at that and talked about it some, and one of the issues there is there's to accurately convey that information, there's about 3 pieces of information for each pesticide. It's going to be the LD50 value, the exposure route, if it's oral or contact, and then the hazard quotient calculation there. And so, since some of these samples have up to like 30 pesticides being found, you saw on that table how it can just be this big long list of pesticides, and then adding more data to that can, we just haven't. We would have to come up with a different way to display that for it to look halfway decent and be readable or understandable, I think. But we might, the one table we looked at where there's you get the level of detection and that kind of information, that might be a good place to put LD50 data that you could then use elsewhere. But we've looked into that. It's just has those complications of how to display that data.
Okay. Next question. Do the axes on your bar charts cut off at 10 Varroa per 100 bees?
Yes.
And that is, just to add in, we find that gives it the best visualization and you don't really lose data that way. And then, so Rachel, did you cover, are we ready to send in the 2020 frozen bee samples?
I haven't yet. Actually, that's a really good point. We should talk about that. So, as of right now, I had told all of the states to not send in any live bees to us. That's because of the situation at UMD hasn't been great as far as getting packages. As of right now, like our building is locked down. You can only get in by key card access, so we can't get any shipments from USPS, FedEx, any of the guys. So there's only one building on campus we're getting everything to. But that being said, we have folks in our department, in our lab, that are going there every day. So we feel comfortable now saying that if states would like to start shipping in live bees, they can. And I will send out an email next week, or probably right on Monday, opening that up so states can start sending in live bees. If you have frozen bees, that's going to be a little bit different. We're going to ask you to ship that to Asher Fund directly. And that reason being is we haven't had very good success because they actually will quarantine packages for 24 hours before we're allowed access to them. And that's not great when you have something on dry ice. So with frozen bees, we're going to ask you to send those to Asher Fund directly. So if you have frozen bees that you would like to send into the lab, please send me an email and I'll give you the instructions on how to do that. So yeah, we're officially open for bees.
And then a similar question, but I'm sorry, sometimes I missed out on what you said, so if you've covered it, but have you discussed sending the live bee boxes again?
Yes, yeah. So if you have you can, as of now, you can start sending in live bees to our lab, and the same address that they're already pre-labeled at, that will get us there. But again, if you have anything frozen, please email me directly, and I will give you instructions on how to ship them directly to Asher Fund. And again, if you have any information at all when you ship your bees, like tracking numbers and things like that, that's really appreciated. Or just send us an email, send me an email saying, hey, I have live bees coming your way. That really helps us, because as of right now, we're not in none of us in our lab are in the building. every day. We're restricted. We can only have 2 people maximum, but even then, we've only been working 1 person in the lab at any given time. So any heads up that you can provide would be very helpful. And that way we can make sure someone's there to receive your live bee sample.
Rachel, I'd like to make a comment. This is Blaine White from Minnesota. I think you're saving a lot of money doing frozen instead of live, and because of the cost of each individual live bee package. And from my perspective, I can sample any day of the week, whereas to ship live bees, I can't. There's days when I can't ship them because they'll arrive on the weekend. Just a comment that to me, it looks like that might be a cost-saving thing as a result of this crazy pandemic situation that you might want to consider going forward. I think it gives us more flexibility both in shipping and in the actual sampling. And as long as the results are the same, it shouldn't matter. We're already shipping the pesticide samples frozen. We know how to do that and have been successful with that. So anyway, for what it's worth.
Yeah, I've made a note of that.
Yeah,
So we
thank
will
you.
have that on our minds in the future. Okay, so yeah, we're running on an hour, but I want to get through everyone's questions. So let me try to ask quickly. And so, should the bee bread samples be frozen after sampling?
Yes, please. So wax is less sensitive. So wax, we've actually talked to the folks at USDA AMS, and the wax samples, it's not vital for them to be frozen on dry ice. So you can keep those in like a refrigerator, ship them with ice packs. But bee bread is definitely the more sensitive of the two. So if you could store bee bread in the freezer until you're ready to ship, that would be preferable.
All right, and then just one more question. Have you considered collecting both pollen and wax from the same colonies for comparison?
That is a really good question. No, we haven't, but that would be a really interesting experiment to do, to see, what overlap there is and what pesticides you pick up in wax and which ones you don't in bee bread. So that's a really interesting question you brought up. We'll definitely think about that.
All right. So just one more question just literally came in just now. Would it be best to send frozen bees with RNA later?
Is this Christopher from Guam? So Guam, so Guam, because of their dry ice situation isn't the best, and they're also very far away from us. So Guam sends us samples on RNA later. So that's definitely an option if you don't have access to dry ice. Nathan and Ashrafan actually have a protocol on how to prepare your samples with RNA later.
And that's all the questions. Karen did mention that we would love feedback from everyone if you have any after this presentation. So I just wanted, that's the last bit of notes that I received.
Yeah, so please reach out to me at the nhbs@umg.edu email address. Let us know what you think about the webinar. If you have any ideas or anything that you want to see for future webinars, please let us know. Anything at all, we would love your feedback. So thank you so much for joining today. And I hope this was helpful for you. All right, everyone have a great day.
Thank you.
Bye.